Exam 2 for Deform is on Friday. And the topics are everything up through stresses and beams. Anybody have any questions related to the test?
Will we be given all the equations that will?
Yeah, every equation you can imagine. I mean, if there's an equation, basically I'll give it to you. So yeah, you don't have to memorize any area moments of inertia or polar moments of inertia or anything like that.
But we will need to know like what A, B, median.
Yeah, that's right.
Or just Q.
Right. Q, yes.
In like one of these. Like Q equals AD. Yeah. And how to work that out.
Yes. Have you ever noticed that, I don't think I might have said this in this class, but you know, one of the, there are two deluxe model beams where we can deal with every single kind of internal load at once. One is a rectangular thin-walled tube, and the other one is a circular solid tube, a circular solid cross-section, but then we can only do it along the neutral axis. And so if you're doing all this stuff for a circular cross-section, then since you're doing it along the neutral axis, Q and I are always the same thing, you know? So, for the stress due to shear force, I mean, you could just calculate it each time, but, you know, this is equal to negative VQ over I times B. B, you know, this has to be along the neutral axis. If you're doing a circular cross-section. So B is always 2R. Q is always the area so this is always your area A. And the centroid is always, you know, this is your distance where that centroid is, what is it, 4R over 3B? It's 3R over 4B? 4R over 3B? That's my final answer.
For the location of the centroid?
Yeah.
It's like 4/3 something.
Okay, yeah, 4R, or not over 3B, over 3 pi, I mean. Is that it, I think?
No one knows. I think so. I know.
It's in someone's notes.
Let's go back. Or R over 3 pi.
Okay, so Q then is the area, which is pi r squared over 2 times this distance, which is 4r over 3 pi. The pi's go away. The 2 makes that a 2. And so you have a q that's always equal to 2r cubed over 3. I is equal to pi over 4 times r to the 4th. And so tau x y is equal to negative v times q, 2r cubed with 3 on the bottom, over, so we got the 4 from this, the pi, and then the r to the 4th. So that's our I. And then we have the b, which is 2r. And so the 2's cancel. And so we get like negative 4v over 3r squared, something like that, 3 pi r squared. And it always has to be that because you're always on the neutral axis. So as a time saver, I might just, give you that formula for the circular cross section if we do a circular cross section.
I'll make it 280.
Okay. I'll make you do the full thing.
There's just white over.
I just have a separate paper for, okay. So let's go back and do this example. And it's going to be the same one we just did. We have a couple of 1,000 Newton meters, a force of 10,000 newtons, this downward force, which turned out to be way, way too big. This was 2 meters long. And then we have a cross section. Where this is 0.1, this is 0.05, the thickness is 0.005, and at the wall, if you calculate those internal loads, you get an internal tension of negative 10,000 newtons, a shear force of negative 5196.2 newtons, an internal torque of positive 1,000 Newton meters, and a bending moment, this is the one that causes the problems, negative 10,196.2 Newton meters. We did this calculation for this point. So now we're going to calculate the stress, and let's calculate the maximum shear stress. At the point on the cross section, I'm kind of exaggerating this thickness. But if this is the neutral axis, let's do it halfway between the neutral axis and the top. So this is going to be a distance from the neutral axis to the top would be half of the height, so 0.05. So this is going to be 0.025 meters. And we want to calculate the maximum shear stress at that point there. Okay? Are you with me on that? Okay, so let's get together with people if you want to work together, compare answers and stuff. I'm just going to give you time to work through this, and then I'm just going to go around and sort of check on your progress as you go. Okay? So it's just a chance to get used to the flow of these kind of problems.